Okay, let's start. We only have 1 hour today. Okay, so it's 8 p.m. to 9 p.m. Okay, so let's start with the probability. Okay, a box contains 15 chips. Okay, n of which are blue and the rest are green. So you see, if I have 15 chips, okay, it's only 2 color. One, the n is blue, so n blue. And the other one means the rest are green. So we will take 15 minus n. That will be our green. So when they ask for probability of getting a green, green is 15 minus n out of the total, which is of course we know is 15. So this is the answer. It's not a number, it's fine, because they say write down in terms of n. Okay? So it's the green over the total. Next, a second chip is chosen at random. Write down in terms of n the probability that both chips are green. So they actually going to take 2 times. And take note over here, you write not replace. Not replace means once I take one chip out, I'm not going to put it back. Okay? So the probability of green, I put it as green. The first green, we already have it here. So it is 15 minus n over 15 multiplied by the second green. So you see, my green initially has 15 minus n. But because you already took out the first green, so that means I only left with, in total, I only have 14. Okay, so we will take 15 minus n minus 1, because the minus 1. So in the end, the second green, I only left 14 minus n. And the total is no longer 15, so it's 14. So you can leave your answer in this form, since it's only 1 mark, or you can just rainbow and simplify. So you will get this, or you can rainbow, you get 210 minus 29n plus n squared out of 210. Okay, this or this also can. Okay, so when it happens together, you multiply. When it's a different scenario, you plus them. So this one is I pick the first chip and then I pick the second chip. So it's 2 things happening together. So it's a multiply. Okay. Okay, the next one. A driving test takes place every month. So Daniel takes a test until he passed and get his license. So they say each time he takes the test, the probability of pass is 11 out of 19. So you must know, if the probability of passing is 11 out of 19, probability of fail will be 1 whole minus 11 out of 19, which will be 8 out of 19. So they say find the probability that he passed the test without a third attempt. Okay, without a third attempt. That means there's 2 scenarios. One scenario is the first time he already passed. Understand? The second scenario is he failed the first time, then he passed the second time. Okay, there's only these 2 scenarios because without a third attempt. Okay, without a third attempt. Without a third attempt. So for this case, it will be probability of pass the first time, or I fail the first time and pass the second time. So if pass the first time means it's straight away just 11 out of 19. Okay, plus the second scenario is fail first. So 8 out of 19. And then after that, after fail first time already, the second time pass. So it's multiplied by 11 out of 19. So it is 2 scenarios. 2 scenarios. First scenario is first attempt pass already. Okay. Second scenario is fail the first attempt, pass the second attempt. Okay? Keyword is without a third attempt. So with this, we will get 297 out of 361, which is equal to 0.8227. Round off to 3SF, 0.823. So you can either leave it in 3SF or you put it in the fraction form, also can. Okay? Yeah, I do teach EMath. my previous life, I've done a lot of EMath questions. So just today that is doing EMath. Let's do the next question. Okay, see over here, we have two tables. So they tell us that this table shows a distribution of 200 students, 100 from this Senoko High School, 100 from this Changi High School. Okay, thanks for the cute wishing bottle. Okay, so they ask, one of the students is selected at random. Find as a fraction in its lowest term the probability that the student is a student from Changi High School who is 15 or more, age 15 or more. So that means you are looking at, so the probability will be 15 or more under the Changi. Look at this. This is between 13 to 14. This is between 14 to 15, 15 to 16, 16 to 17. They want 15 or more. Look at here. There's no equal here. So that means this is 15 and below. 15 or more is here. So that means it will be 31 and 22. So 31 plus 22 out of the total, which is 200 students. So it will be 53 out of 200. Done. What's that cute calendar? Okay. I teach only maths, EMath, EMath. Okay. Next, they again ask, what's the probability that the student is aged under 14? Take note, they never mention school. So it means it can be Senoko, it can be Changi. So age 14, under 14. Under 14 will be here, correct? 32, 14. And so it's, sorry, below 14 is only here, this first column. This is 14 and above, 14 and above. So it's 32 plus 27. So it's 32 plus 27, again out of the total, which is 200. So we have 59 out of 200. Done. Oh no, because you see, they say what's the probability that a student from, it is a student from Changi High School. But they still pick the student from two schools, you see. It's not picking from the Changi High School. That's why it's out of 200. Santa noodles, okay? Yes, because one of the students picked randomly from both schools. They did not mention pick from the Changi High School. Pick from both schools, and what's the probability that it will be a student from the Changi High School who is age 15 or more. That's why denominator is both schools. Numerator is only the Changi High School, 31 plus 22. This, you see, they say age under 14, they did not mention any school, right? So we add the 32 and 27 out of the two schools again. So it's out of 200. So it is 59 over 200. Okay, next part. Two of the students are selected at random. Find the probability that both are from Senoko High School, age under 19. So the first student, okay, Senoko under 16 will be here, 32 plus 14 plus 24 here. So it will be 32 plus 14 plus 24 out of 200. This is the first student, and it is from Senoko, and it is below 16. Now I want to pick the second student, because you see, when you already pick the first student already so-called is already chosen. So you only left with 199 students. So the second fraction will be 199. And the numerator, it will be the same, 32 plus 14 plus 24. But don't forget that because the first one already chosen, right? So you got to put a -1. So in the end, it will become 70 out of 200 multiplied by 69 out of 199. And that will give us 483 over 3980. Done. Okay. So this one, just need to remember that it happens together. That's why it's a multiply. And because one student is already chosen, so the denominator -1. The numerator also -1. And that's how you get two students who are from Senoko below 16 years old. Okay, you need to know how to know when to change the denominator. You have to see whether is it with replacement or no replacement. This one, once you pick the student like step aside, right? So now the remaining students, you know you need to minus 1. Okay, so sometimes it's like, for example, picking up balls. They tell you that, okay, after they pick up the balls, they're going to put it back with replacement. Means after I take the first ball, I put it back. Then you know that the denominator remains the same. But if they say without replacement, means I take the ball out, the ball is outside already, so my denominator need to minus 1 because you only left with one lesser of the ball. Okay? Next, a tree diagram. Okay, so this carton of orange contain of 14 good orange, 14 good, and 6 bad one. So they're going to pick 2 orange at random and see this without replacement. So it means when you pick up the orange, you will not put it back to the carton. You take already means take out already. Okay, so let's take a look at this first one. The first orange, to pick out a good orange, because I have 14 good, so it's 14 out of 20. 14 plus 6, so it's 14 out of 20. Okay, you put it here 14 out of 20, but you always reduce it to a lowest term. 7 over 10 divided by 2 divided by 2. But don't just put 7 over 10. Okay, you need to put the 14 out of 20, then equals to 7 over 10. Because if you don't put 14 out of 20, when you go to the second branch, you may forget that, oh, just now my total is 20. Then if you go and use this, you thought that your total is 10 orange, which is not correct. Okay. Next, so after the first orange is good, you see, you already take out one good orange, right? So initially it has 14. So if one good orange already taken out, you only left with 13 good orange. You only left with 13 good orange. And because the total also become 13 plus 6 already. So it will be 13 out of 19. Okay, so now let's take a look at this branch. This branch is the first orange is good, second is bad. My bad, because I never take out any in the first orange, is good. So my 6, the numerator is 6. But take note, the denominator is already reduced by 1 because they already took out one orange. So it's 6 out of 19. Okay, so over here the bad one will be 6 out of 20. Reduce it, so it will be 310. 310. Okay, now over here. So now, because I already took out one bad, my good, I still have 14. But my total reduced by 1 because I already took out one bad. So it will be 14 out of 19. Okay, this one they already filled it up to you. You can just confirm because I took out one bad already. So 6 minus 1, I left with 5 bad. And then the total is reduced by 1, so it's 19. So it's 5 out of 19, which is correct. Okay, for me is I always make a habit at the side here. This is what you're going to do. You're going to write this is GG, so this is good, good. This is GB, so this is GB. This is B, G, B, and G. B, 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 and B. So why do I like to write this? This tells me that this is both are good orange. This is first is good orange, second is bad orange. This tells me that this is first bad, second good. This is both is bad. Okay, it's easier to see when you put this bracket at the side here. Okay, so this one they just tell me copy and complete the tree diagram, which I already done here. So let's take a look at some of the questions that they will ask for this part. So they will ask you, find in the simplest form the probability that one orange is good and one orange is bad. So one orange is good and one orange is bad. I got 2 scenarios. It can be the first good, second bad, or it can be the first bad, second good. Agree? So this one you will say probability of one good, one bad. I have 2 scenarios. I have good, bad first, or I can be bad then good. Agree now? So I have 2 scenarios. 2 scenarios. That's why when it's 2 different scenarios, it's a plus. And this happens together, so the inside will be a multiply. So let's go back to just now the tree diagram, and let's take a look at GB. GB, here, this one. So you follow the branch. To come to this GB, it will be 14 out of 20 times 6 out of 19. 14 out of 20 times 6 out of 19. So it will be 14 out of 20 times 6 out of 19. This one happens together, that's why it's multiply. This one is BG. Come back to here, go and find BG. BG is here, which is here. So that means you have to 6 out of 20 times 14 out of 19. 6 out of 20 multiplied by 14 out of 19. So it will be 6 out of 20 times 14 out of 19. So in the end, you will get 42 out of 95. Okay, I have a two moderator. If you accidentally say something my moderator don't like, later mute you or block you. It means that you will not be able to see my content forever. Okay, I have no control over my moderator. I let them have freedom to block and mute whoever they want. Okay. Next one, they ask, at least one of the orange selected is good. Okay, so this is a bit tricky. So you can of course see at least one orange is good. So that means it will be this, and this, correct? This is two good, one good, and one good. You can either go and find these three and add them together, or you can actually just find one of them and take one whole minus this, which is even faster. You understand? So, for this, I write probability of at least one good. I can actually write one whole minus both is bad. Agree? So you can either find these three add together or take one whole minus this, you will still get these three one. Okay? So I will go and find my bad bet. My bad bet is 6 out of 20 times 5 out of 19. So it will be 1 whole minus 6 out of 20 times 5 out of 19. And that will give us 35 over 38. Done. Okay. Okay. So let's take a look at this part. They say the second orange selected is bad. Second orange selected is bad. So it's easy. If you look back at the this one, you will see that when they talk about second is bad, this means this one. They are talking about these two scenarios. So it means that probability second is bad. It will be probability of GB plus probability of bad. Agree? So this GB, it will be 14 out of 20 multiplied by 6 out of 19 plus bad is 6 out of 20 multiplied by 5 out of 19. And we will get 3 out of 10. Done. Oops. Okay. Okay, the next one is a bit confused, but hopefully you all understand. Let's take a look at this part. Given that the selected oranges are replaced, see this, this is replaced. So it means that once you take the first orange, you put it back. Okay, and the oranges selected, the oranges are selected n times. That means you're going to pick a lot of times. Okay, so they say write down an expression in terms of n for the probability that none of the orange selected is bad. So probability of none is bad is equals to probability of all is good. So how do you find probability of all is good? Because look at our just now the here. Good, we have 14. So it's 14 out of 20. Right now, 14 out of 20, yeah? And because it is selected n times, so this, you will be like, every time, imagine if it's selected 2 times. Okay, if it's selected 2 times, it will be 14 out of 20 times 14 out of 20, because 2 times, if it is selected 3 times, it will be 14 out of 20 times 14 out of 20 times 14 out of 20, correct? This time round, it said it is selected n times. So it means that it is just this one to the power of n. It depends on how many times. So of course, I reduce it to the lowest term. It will be 7 out of 10 to the power of n. That's all. Okay? Understand? Thanks for the ice cream cone. Oh, I'm craving for ice cream. Okay, let's see. Next, we're going to talk about possibility diagram. Okay, possibility diagram. So they say that, okay, box A contains 3 pieces of paper, label 1, 2, 5. Box B contains 4 paper, label 1, 2, 4, 7. So John picked a piece of paper at random, and then the product of the 2 numbers is calculated. So you can see that this is asking for product, and then when they draw this possibility diagram, and you see at the top left corner they put a multiply. So this is to remind you that I'm going to do multiply. So box A, if they take the paper 1, box B take the paper 1, 1 times 1, it will be 1. 2 times 1, 2. 5 times 1, 5. 1 times 2, 2. 1 times 4, 4. 1 times 7, 7. This one means is 2 times 2, 4. 5 times 2, 10. 2 times 4, 8. So this is the possibility diagram. So from this, you can see all the possible outcome of the paper selection. Is box diagram or tree diagram more effective when doing question? Usually they will not use, if you have 2, you see, one thing about this is you have to have different possibility from each box. It's different, you see, it's 1, 2, 5. Like the box A, you have 3 papers, box B, you have 4 papers. So you want to know, like, okay, box A, if I take 1 first, and then after that the mixture, the different outcome. So possibility diagram is easier to see. Okay? But just now that one is like, okay, I'm going to take the orange, right? The orange, good and bad. Okay? So that one you have to use tree diagram. It's like, oh, first one is, okay, the first orange, it will be either a good or a bad. Then it will be using tree diagram. So actually the question, possibility diagram is easier, okay, but it depends on the questions. Okay, it depends on the question. Okay, so not say cannot, but it's not so easy, because you see, the other one tree diagram, you have 4 outcome only. You only have 4 outcome. So you using tree diagram is easier, you see, because it's only like BB, BG, GB, and GG. Four outcome for the tree diagram. Okay? Okay, let's continue. After this possibility diagram, you got to answer their question. They say, find the probability that the product of the 2 numbers drawn is even. So with this, it will be easier to see the outcome. Okay, only from here, with the outcome, you will know that, okay, which is the product that is even number. So you have, the number of boxes you have will be 3 times 4. So the total outcome you have is 12. What are the numbers that is even? You will have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 outcome out of 12. So probability of even, by looking at the possibility diagram, you can see that you have 8 out of 12 outcome, which you reduce to lowest term, you will get 2/3. And we are done. Then they ask, okay, I want the prime number. So look at the table, prime number. So take note, prime number, smallest number start from the 2. So which are the prime number? You have 1, 2, 3, 4, no more, only 4. Okay, you only have 4 outcome which is prime number. So probability of prime number, you only have 4 outcome which is prime number, and your total outcome is 12. So reduced to lowest term, it is 1/3. Okay? Okay, let's move on to the next possibility diagram. Okay, maybe this one is the one that you talk about the just now, the orange and the blah blah blah. With replacement simply means that your denominator no change. Okay, look at this question. A bag contains 3 good orange. Sorry, see, I talk about orange. This is egg now. A bag contains 3 good eggs. You see, you can use possibility diagram, but I feel that this one use possibility diagram a bit different. You will be a bit difficult. This one, this type, I feel that you go to the tree diagram is easier. Okay, but this one they want it possibility diagram. So let's take a look. So I have 3 good eggs and 1 bad egg, rotten egg. So 2 eggs are taken, one after the other, without replacement. So same thing, it's not going to put back. Complete the possibility diagram to show all the possible outcome. So the first egg drawn, because you have 4 good eggs, so they call it the first good G1, G2, G3, you only have 3 good. So it's G1, G2, G3, and 1 bad egg. Okay? The second egg drawn will be G1, G2, G3, and R. So because we have 3 good and 1 rotten, 3 good and 1 rotten, so you do it in this form. Okay? This one is the same as with, let's see. Just now my... Okay, I will draw it at the side here. So, I will draw this same scenario whereby it is in terms of tree diagram. So, this is first egg. Okay, then after that we have our second egg. Yeah, this one too. Okay, I draw it behind on the foolscap, okay? Because I'm afraid I got no space. I put it here, I draw here. So, I will write the scenario again. So, this time round, I have 3 good egg, 3 good, plus 1 rotten egg. Again, pick 2, right? So the scenario is pick 2 eggs without replacement. So how do you draw the tree diagram for this one? So we will have the first egg. Okay, so the first egg, you can get a good one, and you also can get the rotten one. Agree? Okay, so you will draw these two. So this one, the good eggs is 3 out of 4. So it's 3 out of 4 eggs. So this one, second egg. Second egg. So you will put here, good, and then bad. So let's see. You already picked 1 good egg. So you only left with 2 good egg. So you only left with 2, and because you already picked up 1, and it's without replacement, so it's 2 out of 3. Okay, now this one. I only picked the first one is good. The second one is bad. So that means I haven't taken any bad egg, right? So that means I still have 1. But the total is already reduced by 1. So it's 1 out of 3. Okay, now come to here. So I only have 1 rotten. So it's 1 out of 4. Then I draw this. Good and rotten. Okay, I should use rotten. Okay, this is rotten. So, rotten. Okay, I take out the first egg is rotten. Then my good still have 3 eggs, right? 3, and my total is what? Still 3, So in this case is what? 1 whole. Correct now. Why is it 1 whole, not fraction? Because if I already take out the first rotten, I have no more rotten egg, agree? So this one is actually 0. Okay, so this is 0. Okay, so over here you will see that this is good, good, and this one is good, rotten, and this one is rotten, good. And then this one is rotten, rotten. Okay, oh, so sorry, you are being blocked already. Okay, I wanted to say, if you are so good already, you don't need to have this TikTok live lesson to learn. I'm helping those students who really need help. So if I'm going to go harder questions, okay, I'm not helping those who really need this. Okay, so when you are asking this kind of question, you are only thinking for yourself. Okay, I'm thinking for the majority people. Okay, so don't come out this kind of demanding request. Okay, so I already draw the equivalent tree diagram here. Okay, so let's go back to our possibility diagram. Okay, so over here you can see that, okay, G1 is not possible. You know why? Because if you already pick the first good, you can't be second egg will be the same one. So you can put a cross here. Okay. Okay, so put a cross here. So here will be G1, G2. So you can call this G1, G2 because I pick the first good, second is good. This one will be G1, G3. This one will be G1 and R. So this one will be G1 and G2. This one will be again G2 is not possible, so you can put a cross there. So this one will be G2, G3. So then after that, this one will be G2 and R. This one will be G2 and G3. This will be again cross because cannot be the same both G3. This will be G3 and R. This will be G1R, G2 and R. This is G3 and R. And here is not possible to have both R's, so this one will be crossed out. We are talking about, it's just like, for example, the egg. Okay, the 3 good egg, you label this as G1. The second good egg, you label as G2. Then the third one is labeled as G3. You imagine your first egg, you already pick out the G1 and put it outside. So is it possible that your second egg can be the egg with the label G1? No. Correct? Okay, so this will be the possibility diagram. So now they ask you, find the probability that both the eggs taken are good. So you just look at the G. Okay? So probability is both good eggs. So let's count. You have how many outcomes in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10. Is it 10? Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a total outcome of 12. 2G is 1, 2, 3, 4, 5, 6, 6. So it's only 6 outcome out of 12. So it is half. Okay, so it's 6 out of 12, which is half. Can? Okay, let's move on to standard deviation. Let's move on to standard deviation. Okay, this one I will attach also. So the solution as well as the worksheet will be uploaded tomorrow into the Telegram channel. Okay, over here, I put the formula that will be given. Okay, this is the mean. Okay, this is the standard deviation formula. Okay, now let's take a look. This is a stem and leaf. Okay, give me a moment. So this is a stem and leaf diagram that shows the test score for both the girls and the boys. So they ask you to find the standard deviation of the score for the girls. Okay, because, take a look, please take note that your formula over here, this one, this part, is actually the same as this. In other words, it's actually mean square. This is actually mean. This is actually mean. Okay, so let's take a look and find the mean of the girls first, because I'm supposed to find the standard deviation of the girls. So let's find the mean of the girls. So how do you find the mean of the girls? So the bad news is you have to add all the individual data, because there is no frequency table and all the data is only 1. Okay, so you will have to add 41, 42, 48. So I'm going to calculate the mean first. The mean for the girls, you have to take all the individual number, 41, 42, plus 44, plus 50, plus 53, plus 56, plus 57, plus 63, plus 65, plus 69, plus 73, plus 74, plus 76, plus 77, all the data, and then after that divide by the total number of data you have, which is 14. So it will be 840 divided by 14 and give me 60. So this is the mean, and this is not the answer. This is only part of my working. I will need the mean because my standard deviation formula has the mean. Okay? Of course, some students say that I can key into a calculator and get the answer, right? But I'm not teaching the keying the calculator, because every school, every student use different calculator also. I always use the manual method, which is the formula, because formula is given to you. Okay, so standard deviation. So let's take a look at what the formula means. Look at over here, this part. What does the fx square mean? X is your data. Okay, f means it depends on how many data you have, right? For this case, all the data only appear one time. So all the data is 1, the frequency is 1. You understand? Okay. So what I'm going to do is, then this one is sum of, so you have to add them together. So this one is a bit very tedious. So what I need to do is, I have to take fx square. F represent because I only have one data of 41. I only have one data of 42. Okay, because it's x square, because it's x square. You see this? It's x square. And then I have one data, so I have to do all of them. So it's 44 square plus 150 square plus 156 square plus This one you should know lah. Just continue until the last one, which is 177 square. The whole thing over sum of f. Sum of f means sum of my data, which in this case I have 14. So it's divided by 14 and minus the mean square. Mean just now I already calculate, which is 60. So just now this whole thing, okay, I need to minus 60 square. I need to minus 60 square, and then don't forget I have to do a square root. Okay, so I have to do a very big square root, and I will eventually get 12.363 12.4 3SF. Okay, so let me explain again the formula. So fx squared, x, for this case it is because my data only have 1, so that's why my 1 is here. The data square plus 1 data square, sum of it means you add all of them together over the sum of f. Sum of f means your sum of your data. Okay, for this case is 14. This is mean, and I already find my mean in the first part over here, which is 60. So I minus the 60 square, and then I put a square root, and that's how I get my standard deviation. Okay, let's move on. Okay, so now this one's slightly different already. Now my data is no longer one data. Just now it's like I only have 140, 141, 143, correct? Now is they give you a range. It's a range. My range is, they tell me, okay, the range from 30 to 40, I have 10 of it. That means I have 10, this one is talking about what? This is talking about the WhatsApp message sent by 100 male students, okay? So this table tells me what? This table tells me, okay, I have 10 students, okay, who send between 30 to 40 message. But of course, 40 is not included because there's no equal at 40. I have 13 students, 13 boys, who send between 40 to 49. I have 40 students who send between 50 to 59. And da-da-da-da-da. Okay, this is how you understand from this table. Whenever you have a range, you need to find the mid number of each range. Understand? So how do you find the mid number? You will have to take 30 plus 40 divided by 2. So it will be 35, 45, 55, and 65, and 75. Whenever you have a range of data, you need to find the middle, the mean, the middle. So you have to take the two extreme number, add them together, divide by 2. Okay, so it's 30 plus 40 divided by 2. Maybe first one I write here, 30 plus 40 divided by 2. So the rest I don't need to write, you should know. And then, okay, first one, part 1, no, it's very easy. They ask what percentage of the male students send less than 50. Less than 50 is these two numbers, right? So it will be 10 plus 13 out of 100 male. This is a fraction. Change it to percentage. Just nice denominator, and this one is 100. So it's straight away 23%. This one very straightforward. Nothing much. Next, they ask, calculate an estimate of the mean number of blah blah blah. So sometimes students ask, why is that suddenly they ask the word estimate? Because you look at this one, this is a range, correct? We do not know what is the exact number of message that the student send out. It can be everyone is at 30. It can be everyone is at 39. Or it can be random. So we don't know what is the actual data. So we are taking the middle, 35, to do our calculation. So that is why it's an estimation. You understand? That's why it's called an estimation. So same thing, the mean, I will just take 35 times 10. So the mean, we'll just take the middle, which is 35 times 10. Okay, plus 45 times 13, plus 55 times 40, plus 65 times 16, plus 75 times 21. The whole thing over the total number of male students, so which is 100. So we will have 5750 divided by 100. We will have 57.5 message sent per student. That's the average, that's the mean. Okay, so now let's move on to the next part. Now they ask you to calculate the standard deviation of the number of WhatsApp message sent. This is different from just now. Remember just now, our F is 1, right? Our F is 1. See? Our F is all 1. But these male students, the F got number. So for this case, it will be Fx square, right? So it's 10 35 square. Okay, 10 35 square. Okay, plus 13 45 square plus 40 55 square plus 16 65 square plus 21 75 square. The whole thing over the number of students, which we know is 100, and minus the mean square. Just now you already calculate the mean. And put the big square root. And you will get square root 345300 over 100 minus 57.5 square. And your standard deviation will be 12.11, round off to 3SF, 12.1. Right? Okay, the next one. Now they ask you to give a theory comparison. So now they tell you, okay, I give you another set of data. They tell you that the mean number of WhatsApp sent for the 100 female students was 60, and the standard deviation for the girls is 11. So they ask you to make two comparisons between the number of WhatsApp message sent by the male and the female. Okay, so I'm going to write down the information so that we can see easier. So the boys mean, we have 57.5. The girls mean will be 60, which is the one that give us. The boys standard deviation is 12.1. The girls standard deviation is 11. So based on this, you're going to give two comparisons. So let's take a look at the mean. Okay, so the mean can tell us what? The girls' mean is higher than the boys' mean. So this tells us what? This tells us that the female students send more WhatsApp messages. Okay, then you have to say compare with the male than the male, and you must tell them why, right? So it's because the mean is higher. This is based on the mean to give a comparison. Next, let's take a look at the standard deviation. So what is standard deviation? Okay, the smaller the standard deviation is, it means that your data are all very packed together. That means they're very close to each other. Okay, so it means that hello, Teacher May. Okay, so boys standard deviation. So the smaller standard deviation you have is it means the data are very close together. In other words, are more consistent. So use the keyword. If the standard deviation is smaller, it means that they are more consistent. So with this, you can see that the girls' standard deviation is smaller number, right? So you will say, based on this, you will give the statement that the number of WhatsApp message sent by the female students is more consistent. So the keyword is more consistent because it has a lower standard deviation, means that the number of message, the data is same, almost the same number, very packed together. That's why it's called more consistent. You understand? I ask my students come here to revise, coming in to check if they are here. Oh, they never reply you, so that means they are not here. Okay. So this is how you're going to give the two comparison based on the mean numbers as well as the standard deviation number. Okay, let's move on to the next question, which is in fact the last question for the day. Okay, so let's take a look. Now, I have the data 880, a fixed data. So it's no longer a range, and then my F is also no longer 1. Okay, so but the formula is always the same. First, the mean. Mean is very straightforward. The mean, you just take the data 880 times 5 plus 920 times 7 plus 950 times 8 plus 980 times 2 plus 1020 times 1 plus 1050 times 2, and the whole thing over the total number of workers. Of course, you can plus, but you can read the question that you can see that there are 25 workers. So it's out of 25. So you will get 23520 out of 25, and that will give us, and because it's wage is a salary, which is money. So straight away it's $940.80. Take note, when you talk about money, you got to put in 2 decimal places. You cannot put $940.8. Doesn't make sense. So it's 0.80. So that's the mean wage. Next, they ask you to find the standard deviation. Again, let's go back to the formula. By now, you should memorize. You already know how the formula works. So you can see that they ask for fx squared, and your x is your data. Okay, your x is your data. If your data is a range, take the middle number. If your data is already just a fixed number, that is your x. So frequency means how many of that data I have. So fx squared, f x squared. This is called fx squared, and it is sum. So I'm going to add, this one will be 7,920 square plus 8,950 square plus 2,980 square plus 1,1020 square plus 2,1050 square over 25 minus the mean square. Mean is already here, so it's just minus 940.8 square, and don't forget the big square root. Okay, the big square root, standard deviation. So we will have 47.0676, and that will give us, again this is wage, so it's money. Money round off to 2 dp, so it's 47.07, 2 dp. Done. Okay, this last part, a lot of times they like to ask this question. So now they tell you, the wage of each of the 25 worker, they increase by $25. Okay, everyone increased by $25. So they ask you to calculate what is the new mean and what is the new standard deviation. Okay, your original mean was 940.8. If everyone increased by $25, it means that my mean is also increased by $25. Okay, so your new mean will be taking the old mean, which is 940.80 cents plus 25. So it will just be 965.80. Okay, 965.80. Now, what is my new standard deviation? Okay, remember just now I mentioned that standard deviation is how consistent your data is. So imagine everyone is like 880, 920, right? And after that, everyone add 25. So actually, all the data are shifted 25, but the consistency is still the same, right? Consistency is still the same because everyone adds 25. So the standard deviation I don't have to calculate because there is no change. Standard deviation, no change. Okay, no change. And that's about all. So basically today I cover probability. I got do the simple one. I got do the tree diagram, possibility diagram, and then after that I do standard deviation. Okay, so this will be all for today. Okay, I hope by now you all should know how to calculate standard deviation. And because the standard deviation formula is given, so just by looking at the standard deviation formula, you know what you should do. Okay, now let's take a look at my next TikTok live schedule. Why no change? Because everyone is increased by, all the 25 workers increased by $25. Standard deviation is how consistent is your data, the consistency of your data. Okay, my standard deviation is 47.07. Okay, and all the data is plus 25. So it's like everything is changed. So the in other words, the space between all the data is still the same one, because everyone changed by 25. So the standard deviation in the deviation is still the same. That's why standard deviation remains unchanged. Understand?